Thank you everyone for joining me today. My name is Victoria Carthew and I'll be leading you through your lessons. Coming up, we have English, where we'll learn about narrative texts. In maths, we'll be looking at drawing to scale. And in science, we're going to discuss some everyday objects that came from concepts that were first tested in space. Let's start by turning our attention to English, in particular to narrative texts. There are many different types of narrative texts, and today we'll hear about two of them.
Hi everyone, I'm Chris. Do you enjoy reading? One of my favourite things to read are narratives. I love the way you can get lost in a story. What about you? Today we are going to look at the narrative texts and how short stories are different to novels. But first, let's remind ourselves of what narratives are. A narrative is a story of events or experiences, real or imagined. Short stories and novels are both examples of narrative text. Can you think of any short stories that you have read? What about fairy tales? Or folk tales from other countries? Or fables? Aboriginal dreaming stories? Or even those stories told at family gatherings? Have you ever wondered what makes a short story different to a novel? I have an idea. Let's play a game. I really enjoy playing games to learn new things. I'll be the game show host and you can be my contestants. Here's how the game will work. I'll say some statements about short stories and novels, and you will have to decide if the statements are true or false. Are you ready to play? Okay, let's get started with the first statement. Is this statement true or false? The length of short stories and novels is similar. What do you think? True or false? This statement is false. One of the major differences between a short story and a novel is that the short story is, well, shorter. Shorter in length, which is why it's called a short story. Long ago, short stories were told and not written. Therefore, they had to be reasonably short so that they could be remembered and shared. Are you ready for the next quiz statement? Let's continue. Tell me, is this statement true or is this statement false? Short stories and novels both have a narrative structure. True or false? This statement is true. Both short stories and novels have a narrative structure. That means they both have an orientation, or a beginning, a complication, which is a problem or a conflict, which works up to a climax, and then finally a resolution, an ending where the problem is overcome. Short stories have a much simpler plot, with usually only one complication. Are you ready for our next quiz statement? Okay, here it is. Is this statement true or false? Novels only have one or two locations for the setting and only one or two characters. True or false? This statement is false. Did you get this one right? Let's think about why this statement was false. Remember, we said before that short stories are much shorter than novels. This means short stories usually only have one or two locations for the setting and usually only one or two characters. They just don't have time to introduce lots of characters and different settings as well. Novels, on the other hand, have a much longer length, so they can usually include more characters and more settings. Are you ready for the next quiz statement? Alrighty, let's continue. Is this statement true or false? In a novel, there could be multiple conflicts that a character must overcome. However, in a short story, it is usually only the main character who faces a conflict. True or false? This statement is true. A conflict is a clash, usually between the main character, who we sometimes call the protagonist, and the opposing character, or the antagonist, often based on differing views, ideas, or opinions. This is an example of an external clash. That is, the main character is struggling with another character. Other examples of external conflict are when the main character clashes with a cyclone or a wild animal, something that is outside them and that they have little control over. However, the main character could also be struggling with something that is internal, such as a strong emotional reaction or a difficult decision or challenging their own thoughts. Are you ready for the next quiz statement? All right, here we go. Is this statement true or is it false? Novels, unlike short stories, may have more than one theme because of their length. True or false? This one's true. Remember, the theme is the underlying message or lesson that we learn from the story as a result of the actions or the events that overcome the conflict or complication. It is the main idea or message of the narrative. Novels may have more than one of them because of their length. Alternatively, short stories usually only have time to deal with one theme. Are you ready for our final quiz statement? All right, here we go. Short stories share the same language features as novels. Remember that language features support meaning. For example, things like sentence structure, noun groups and phrases, vocabulary, punctuation, or figurative language. So with this in mind, let's see if this is true or false. Short stories share the same language features as novels. This statement is true. Both short stories and novels are narrative texts. They use the same language features to tell a story or event or experiences, real or imagined. Authors of both short stories and novels can use different types of sentence structures, nouns, noun groups, verbs and verb groups, or even figurative language to tell their stories. It is the choices authors make in how and when they use these language features in short stories or novels that may be different. I think our questions definitely got trickier. But wow, that true or false game was a really fun way of understanding how short stories and novels are similar but have some differences. Short stories and novels are similar because they both have the elements of a narrative, which include things like themes, plots, characters and settings. And of course, they are also an excellent form of entertainment. The differences between short stories and novels are largely due to the difference in their length, which has implications for how the author develops the plot, the complications, the characters, and the settings. It may also impact on how the author uses language features. Although there are differences between short stories and novels, there are also many similarities. Why don't you spend some time reading a short story or a novel? Share what the story is about with a family member or a friend, and let them know what you like about the plot or the characters. See you next time, guys. Bye.
Let's move on to maths. To design and build a structure like a high-rise building, we use a scale drawing or model. We call it a scale model because even though it is much smaller than the real object, all the elements of the design are the right size compared to each other. Think about a doll's house as an example. It is smaller than a real house, but all the furniture and appliances are also smaller, so they fit into the doll's house in the same proportion as a real home. Here's Will with more.
Welcome, everyone. Scale drawings allow us to accurately represent spaces and details to a smaller, more practical size. Homes, mines, basketball courts, huge city buildings and even spacecraft have all been designed and constructed using scale drawings. And we use scale models in science when we explore the Earth, Sun and the Moon. Now, I'm thinking I'd like to change up how my bedroom is arranged. I want to know what the best arrangement for the furniture is going to be. We are going to need to make a scale drawing of my room and its furniture. To do this, I'm going to need to know a little bit more about enlargement, reduction and scale factor. Let's start by reviewing those words: enlargement, reduction and scale factor. Let's try creating an enlargement on this geoboard. Take a look at this shape. What are its dimensions? It is a rectangle that is 2 squares along the length and 1 square along the width. Let's see if we can enlarge this rectangle by a scale factor of 2. This means we have to multiply each dimension by 2. So the length will be 2 squares multiplied by 2, which is 4 squares, and the width will be 1 square multiplied by 2, which is 2 squares. This shape is enlarged because it is larger than the original shape. It has been enlarged by a scale factor of 2 because each side of the new shape is 2 times the size of the original shape. So the new shape has a length of 2 squares multiplied by 2, which is 4 squares, and a width of 1 squared multiplied by 2, which is 2 squares. Shapes can also be reduced in size. Let's look at reductions. We'll start with a triangle that has 6 squares along its base and 4 squares along its height. Let's see if we can make a triangle that is reduced by or has a scale factor of a half. A scale factor of a half means that each side of the new shape is a half of the size of the original shape. The original shape's dimensions are divided by 2. So the base of the new shape is 6 squares divided by 2, 3 squares along. The new shape's height is 4 squares divided by 2, which is 2 squares high. We can see how the original shape has been reduced to make a new shape that is smaller. Let's take a look at how to calculate the scale factor. We'll start again with a rectangle that is 2 squares along the length and 1 square along the width. But this time we already have a new shape too. It is 6 squares along the length and 3 squares along the width. Sometimes we want to know how big or small an object really is, and the scale factor can tell us this. For example, this is a model of the Earth. It was made using a scale factor of 1/40 millionth. That is, the Earth is 40 million times larger than this globe. Now, let's look at a smaller example on the geoboard. To calculate the scale factor of a drawing or model, we ask ourselves, how many times do we multiply the length of the original shape to get the length of the new shape? The original shape had a length of 2 squares and the new shape has a length of 6 squares. So 2 multiplied by something became 6. 2 multiplied by 3 is 6. The original shape's length multiplied by 3 is the new shape's length. The scale factor described how the shape has been enlarged or reduced. So I think the scale factor is 3. We need to check it by comparing the shape's widths. The original shape had a width of 1 square and the new shape has a width of 3 squares. Does 1 square multiplied by our scale factor of 3 give 3 squares? Yes, it does. Our scale factor must be 3. We can say that the new shape is 3 times larger than the original shape. So now that we know about enlargement, reduction and scale factors, we can apply this mathematics to create a scale drawing of a bedroom. Let's create a plan. We'll start by making a scale drawing of a room, and then we'll add in the furniture afterwards. Is it going to be a reduction or an enlargement? The drawing will be smaller than my bedroom, so it will be a reduction. What information do we need to gather? And where will we get this information from? We'll need to know the length and the width of my bedroom. Architects and builders work in millimetres when planning buildings, so we're going to work in millimetres too. I measured my bedroom and found that it is 4 metres by 2.5 metres. When we convert this to millimetres, we multiply by 1,000. So my room is 4,000 millimetres in length and 2,500 millimetres in width. Now we can work out the scale factor. We need to create a factor that will reduce the size of the room to fit on this piece of paper. Let's compare the size of my room to the size of the paper to estimate what scale factor could be used. My room is 4,000 millimetres long and 2,500 millimetres wide. My piece of paper is 420 millimetres long and 297 millimetres wide. Can you see a relationship between these numbers that could help us out? I see that the length of the paper, 420 millimetres, is about 10 times smaller than the length of my room, 4,000 millimetres. We could try using a scale factor of 1/10. We need to check if our chosen scale factor is reasonable for the width of the room and the paper. Is the width of the paper 297 millimetres, about 10 times the width of the room, 2,500 millimetres? Yes, it is. So a scale factor of 1/10 will work in this situation. The drawing will be 1/10 the size of my bedroom. Let's create our accurate scale drawing using these measurements. We'll calculate the exact length first. 4,000 millimetres divided by 10 is 400 millimetres. We can draw a 400 millimetre line across the page here. Now, let's calculate the exact width. 2,500 millimetres divided by 10 is 250 millimetres. Let's draw that along the width. Now that I know the scale factor, I can use reduction to draw a scale drawing of my furniture. I can even do the furniture scale drawings on different pieces of paper. Then I could cut them out and move them around inside the bedroom. Here's an example. There's my bed, there's my table, and the doorway in the corner. Today, we've created enlargements, reductions, and we've calculated scale factors and used our new knowledge and skills to create a scale drawing. Later, maybe you could make a scale drawing of your bedroom and help rearrange it. Or you could use your imagination and create a scale drawing of our dream house. Perhaps you could even plan a veggie garden. See you next time.
Thank you, Will. We have been thrilled to see students expressing themselves in artistic ways while they've been spending time at home. So let's watch some of them with a dance routine that has a lovely, positive message.
Mama said, don't give up, it's a little complicated, all tied up, no more love, and I'd hate to see you waiting. They say it's all been done, but they haven't seen the best of me, so I got one more run, and it's gonna be a sight to see, Had to have high hopes for a living, didn't know how, but I always had a feeling I was gonna be that one in a million. Always had high hopes. Had to have high hopes
you watch Learning at Home TV regularly, then you'll be very familiar with the fact that we stop for brain breaks. I'm not going to ask you to get up out of your chair this time, but I would love you to listen to some great information about why movement is important.
Hi, I'm Jason.
Hi, I'm Evie and I'm in grade 4.
Thanks, Evie. Can you tell me ways you like to stay active?
I like to jog on the spot and run up and down the hill.
Running up and down the hill, geez, that must be pretty hard work.
Sometimes.
Sometimes? Feels good to work hard sometimes too,
Yeah.
doesn't it? That's excellent. So why is it so important to be active every day?
To keep your muscles strong and your bones nice and healthy.
Absolutely, and those other organs in your body as well, like your heart and lungs and those sort of things too, isn't it?
Yeah.
Yeah, absolutely. So do you know how long you should actually be active for every day?
60 minutes, about 60 minutes every day.
60 minutes every day. So that's moderate to vigorous activity. So we're actually thinking like, you know, lifting our heart rate up, breathing pretty heavy, those sort of things. Yeah, absolutely. And what does it feel like when you are being active with moderate or vigorous figure?
Well, you might feel a bit sweaty or hot or exhausted or tired.
Absolutely, and those are all very normal feelings, aren't they?
Yeah.
Because afterwards you actually feel really good after you've done that physical activity. Look, Evie, thank you very much for sharing with me and your ideas on how we can stay physically active every day. Hope you're having fun being active at home, guys, and we'll see you next time.
The Apollo 11 space mission that resulted in the moon landing 51 years ago is important for many reasons. A lot of the technology NASA used for the spacesuits worn by the astronauts was later modified and repurposed for products that we use today, including memory foam mattresses, scratch-resistant lenses and sports shoes. Today in Science, we will explore the design of the spacesuits and how it allowed astronauts to survive the harsh conditions they encountered once they stepped outside the lunar landing module.
In 1969, 3 astronauts, Neil Armstrong, Buzz Aldrin and Michael Collins, were part of the Apollo 11 space mission and were the first people to walk on the moon. This was a remarkable and historic achievement for humankind. But have you ever wondered why astronauts wear spacesuits to the moon? They keep astronauts alive in the harsh conditions of space. This means that when designing spacesuits, scientists have to carefully consider the moon's environment. Let's recall the features of the moon's environment in a game of true or false. For each of the following 5 statements, call out if you think it's true or false. Are you ready? Statement number 1. The surface of the moon is dry and rocky. True or false? True. In earlier missions, astronauts made observations and collected samples of the moon's surface to confirm this. Statement number 2. Humans can breathe easily on the moon because its atmosphere is like Earth's. True or false? False. There is no oxygen on the moon. Statement number 3. Radiation from the sun is much stronger on the moon than on Earth. True or false? True. The moon does not have an atmosphere to provide protection from the sun. Statement 4. The temperature on the moon is like the temperature on Earth. True or false? False. The temperature when the sun is shining directly on the moon can be as high as 127 degrees Celsius. That's hotter than boiling water, which is 100 degrees Celsius. Finally, statement number 5. The gravity on the moon is stronger than the gravity on Earth. True or false? False. The gravity on the moon is much less than that on Earth. That's because the moon is smaller and has much less mass, so it pulls with less gravity. 1 kilogram on the moon would only feel like 160 grams. Wow, the moon's environment really is harsh. Scientists had to consider all of these things when designing the spacesuit for the moon. Let's take a closer look now at how it was designed. This photo shows the type of spacesuit worn by Neil, Buzz and Michael. It is a one-piece suit, but they also wore another suit beneath it. That's why it looks so bulky. This second suit is a liquid cooling garment, or LCG. It looks like long underwear with clear plastic tubes running through it. If we look carefully at this photo, we can see the tubes. Cool water circulated through the tubes and this protected the astronauts from the high temperatures. It also reduced sweating and fogging of the helmet, which allowed the astronauts to see clearly. Do you think the colour of the outer spacesuit is important? Yes. Have you noticed that when you're in the sun, a darker coloured shirt makes you hotter than a lighter coloured shirt? Remember, temperatures on the moon can be extremely hot, so scientists designed the spacesuits to be white because white reflects heat in space just like it does here on Earth. The astronauts also carried a portable life support backpack. It contained oxygen for them to breathe because there is no oxygen on the moon, and it removed the carbon dioxide they breathed out. It also carried the cooling water that was pumped through the LCG. The last part of the spacesuit is the helmet. It is a transparent bubble designed to attach to the neck ring, creating a sealed pressure unit, keeping their air inside. Wow, there's a lot in that spacesuit. In fact, it took the astronauts 45 minutes to put it on, and all up, the suit weighed 91 kilograms on Earth. But because of the lower gravity on the moon, that downward force would have only been 15 kilograms. Now, take a look at this helmet. It is different to what we just saw. It was worn over the top of the pressure bubble helmet and had two visors that could be lowered. Why do you think the astronauts had a second helmet? It helped protect against the sun. One of the visors was covered with a thermal coating to protect against the heat, while the other was covered with a gold optical coating that acted like a sun shield or sunglasses, protecting against the sun's radiation. Scientists also had to carefully consider shoes for the astronauts. Their boots were made with a silicone sole and woven stainless steel uppers to protect against the sharp rocks on the moon's surface. An overshoe provided extra protection from rips, tears, and dust. They also left distinctive footprints, which you can see in this photo. Because there is no erosion or weathering on the moon, these footprints are still there today. Now, take a moment to think about all of the technology that we currently have at our fingertips. In 1969, the internet did not exist, and one single computer was actually as big as a classroom. In fact, a smartphone has much more computing power than scientists even had access to in 1969. And that makes the design of the spacesuit incredible, as it allowed a successful and safe moonwalk for the first humans on the moon. An amazing technological achievement. Okay, let's recap what we've learnt today. We now know that the spacesuits worn by astronauts had to be carefully designed for the harsh conditions on the moon. And the spacesuits were developed over 50 years ago and represent a significant technological achievement. Now it's your turn. Do you know anyone who can remember watching the Apollo 11 moon landing on TV back in 1969? Ask them about their experience of watching this event and how significant it was for the science and technology of the time. Or perhaps you could design a spacesuit for landing on the moon of another planet in our solar system. Thanks for watching. See you next time.
My uncle remembers that moon landing very well. It was his 7th birthday and he was allowed to take the day off school to watch the event on television. He says he sat there in his new birthday pyjamas with his eyes glued to the screen. He couldn't believe that it was happening. And on that note, I'll say goodbye for today. Thank you for sharing your lessons with us. We'll be back again soon. And in the meantime, I hope you stay healthy and happy and look out for each other. Bye-bye.
Authorised by the Queensland Government, Brisbane.